my name is Carrie Williams and I'm a science teacher in California. And today I'm going to take you through the first 3 days of lesson 1 because you were probably absent for 1 or more days of this portion of the unit. So for day 1, you're going to need a science notebook, writing utensils or something to write with, and the resources found at this bit.ly link you can see at the bottom of the screen. It's bit.ly/P2 DAY1. And there will be a few links there that I will tell you to access as we go through the day 1 resources. All right, if you need more time, go ahead and push pause. Otherwise, let's get started. So we're going to explore a new phenomenon as we kick off this unit. In October of 2005, people in Northeast Africa took this photo of a huge crack in the ground that was not there before. Now, if you want to get a sense of how big this crack was, you can look at the side of the photo right here. You can see those are people standing on the side of the crack. And so this is a very large crack in the ground. Now, your class kind of discussed what might have caused this change in Earth's surface, but I want you to think to yourself, what could have caused this change in Earth's surface? So think about it for a moment. What would you like to know more about in relation to this event and the area where it occurred? What would you want to know about how this crack appeared? Often people ask if anyone was injured, was there an earthquake or a special weather event? So think about what would you want to know to be able to explain what happened in this photo? I'd like you to go ahead and open your notebook, or you can just use a regular piece of paper and set up a T-chart with a notice and wonder. So what I noticed would be along the left side of the T-chart, and then what I wonder is on the right side of the T-chart. And I'm going to share with you the story map, which gives you a lot of information about how and when this event occurred. And I want you to record what you notice, your observations on the left side of the T-chart, and what you wonder on the right side. Your resource that you're going to open is called Story Map. And remember, here's the link right here where you can access the story map. And go ahead and push pause at this time. And when you're ready to resume, push play. Your class then discussed what they noticed and wondered and shared out what they wrote down in their T-charts. So let me go through some of the common things that are shared out. Number 1, there was a volcanic eruption. There were lots of earthquakes and aftershocks that occurred before and after that crack formed. The crack is not located on a plate boundary. The earthquakes occurred on fault lines. The land is really low in this area. It's below sea level. The land to the left and the right of the crack moved in different directions and also changed elevation. And also people generally feel earthquakes that are over a magnitude of 4. What people wonder normally is, did the volcano's eruption cause the crack? How long will this keep going? What is a fault line? So some people might have shared that it occurred on a fault line, or you read that it was on a fault line, but you may not know what that is, or you might not know what a plate boundary is. Does this only happen in the desert because the land is dried out? Can it happen where I live? And how do earthquakes happen at places that are not on plate boundaries? So probably you had some of the very similar observations and questions when you made your notice and wonder chart that other people have shared in class as well. Your class also shared some personal experiences. So I want you to think about what experiences you have had with some of the phenomenon that we see in the Afar region. And what do we know about earthquakes that might cause them to happen in some places but not others? Or can earthquakes happen anywhere, even at non-plate boundaries? So a lot of people share experiences related to earthquakes, especially being from California. Students in my area are very familiar with earthquakes, more common than volcanoes. But think about to yourself, have you experienced any of this stuff that we read about in the story map? So it makes sense to start with earthquakes since that's what most people have experience with. And there's a way that we can look for patterns of where potential earthquakes could happen. What patterns do you think you might notice when looking at where potential earthquakes happen, or at what scale might you see those patterns? I want you to think about that as we move into our next activity. So I'm going to share with you a plate boundary map, and it has some information about earthquakes and where they occur. And with this, I want you to think about, do earthquakes happen in your region? What patterns are you noticing? At what scale are these patterns being seen? And what might we expect, or why might we expect earthquakes to happen in some places but not others? So as you look at this map that I'm about to share with you, I want you to kind of be thinking about these patterns and these questions, and I will share them again with you in a moment. Before we get going, I want to share a quick video with you to explain how to use the plate boundary map. So go ahead and listen as this video plays.
Today we are looking at our earthquake and volcanism map. This earthquake and volcanism map can show us several different things. The blue dots indicate earthquakes. If you click on a blue dot, you can learn more about the earthquake that you're looking at. These red triangles represent volcanoes. You can also click on the volcanoes to learn more about them. And finally, our pink lines represent plate boundaries. We can navigate this map in several different ways. The first one being by using these plus and minus arrows. If you click on the plus, it zooms us in. Of course, if you click on the minus, it will zoom us out. We also have the default extent button, which will take us back to our original viewpoint. Finally, we have the location button. So if you have your location set up in your browser settings, you can click on this button and it will show you and take you to your location. In the upper right-hand corner, we also have 3 buttons here. The first one is the legend. So you can open up the legend and it will remind you what these different symbols represent. We also have a layer list. So if you want to remove all of the volcanoes from the map, you click on volcanoes and it takes them off of the map. You can also add them back on by clicking on volcanoes. Same thing with world earthquakes and your plate boundaries. You can also remove the state boundaries. Finally, we have the swipe feature. What the swipe feature does is it can add and remove earthquakes from the map by swiping across the screen. So you'll notice as I move to the left of the screen, it actually removes the earthquakes from my view. I can move it back to the right, and then I can see where the earthquakes are. This allows us to see how the layers correspond to each other. Have fun exploring the earthquake and volcanism map.
Okay, so I'm going to share the earthquake volcano map with you now. You're going to use that bit.ly link you see in the bottom of the screen, which is bit.ly/P2 day 1. If you go there, you're going to open up the earthquake volcano map. And as you're looking at it, I want you to really consider and also take notes in your notebook about, do earthquakes happen in your region? What patterns are you noticing? And at what scale are you seeing these patterns? So those first 3 questions, take some notes in your notebook about the earthquake volcano map, and then also be thinking, why might you expect some earthquakes to happen in some places but not others? Take about 5 minutes, go ahead and push pause, and when you're done, go ahead and come on back to the video. So now that you've taken some time to identify patterns using this earthquake and volcano map in your notebook, I want you to think about at what scale are you able to see these patterns? So I'm pretty zoomed out here. Here's a screenshot of the tool you just used, and you can see that we've got some plate boundaries, these lines where the earthquakes occur, and we can see it at that scale. Can you see any patterns in the middle of the United States, or at what scale can you see what's happening maybe at the state level? Right now it looks like we just have a whole lot on the West Coast right here. Let's go ahead and move to zoom in a little bit to the state of Missouri, which we can't really see much patterns going on right here. But as we zoom in to the southeast corner of Missouri, you can see that Missouri does not have many earthquakes. But you can see this southeast corner has quite a few. So there is a pattern here. In the state of Missouri, we've got an area where more earthquakes occur. Now, this is not on a plate boundary. So we had to zoom in to see this pattern. And I'm wondering, why might we expect earthquakes to happen like on plate boundaries, but we don't really expect them to happen here that we can see on a smaller scale? And how might these earthquakes that are not on a plate boundary help us learn more about the earthquake in afar? So now I'm going to ask you to look for some similarities and differences between some earthquakes. And there are several case studies, and you're going to select just one of the case studies to read. And you're going to compare that earthquake that you're reading about in your case study to the events at afar. Think about what is similar, what is different. You can use your notice and wonder T-chart to help you remember what you noticed and the observations you collected. And then also think about, is there anything else that might help explain why these earthquakes are occurring? Now, these questions can be found on the handout Case Comparisons, also found on our resource link. And then you will find all of the different case studies on the same resource link under Earthquake Cases. So remember, you're just going to select one, and you're going to fill out step 1 of the handout, Case Comparisons. So go ahead and push pause here, and when you're done with the step 1 on that handout, and if you don't have a printer, you can just use a piece of paper or your notebook to write down the similarities and differences, but use the handout to help guide you through. So pause here, and when you are done looking at a case study and recording everything for step 1, you can go ahead and resume the video. So in class, everybody shared what they learned about their case studies and got into groups and did a bit of a jigsaw with these case studies. I want you to listen as I read through the case studies. You did one of them. I'm going to read all of them. And I want you to think about what is similar between the earthquake in your case study and the other case studies or the afar events. So you're going to write down what is similar in the left side of the table and on the right side of the table, the differences between the earthquake I'm talking about and the other cases or the afar events. So go ahead and write this either in your notebook or on the handout for step 2 as I read through some of the different things that were found for the other case studies. So the first case study is the 1812 Madrid earthquake. This was located in Missouri along the Mississippi River, and there were 3 major earthquakes, 7.0 or larger. Trees were knocked down, the ground was lifted up, the riverbanks collapsed, and there were many aftershocks. A trench formed during the earthquakes, and there are a series of faults in that area. So what I just read, if there was anything similar to your earthquake case study, go ahead and put it on the left side. Anything you heard that was different, you're going to put on the right side of that table. All right, case 2 was the Denali earthquake in 2002. This is located in Alaska. It was 7.9. That's a fairly large earthquake. It was located on 2 fault lines. The ground changed in elevation by 24 feet. It moved roads and streams. The land shifted sideways by as much as 29 feet. A crack in the ground appeared and it was 200 miles long. Landslides and rock avalanches occurred, and it triggered other small earthquakes in California and Utah, as well as thousands of aftershocks. Okay, case study number 3 was in 1925, and I'm not sure if I can pronounce this correct. It's in Canada, the Kamouraska earthquake. Sorry, forgive my pronunciation. It was a 6.2 earthquake in Canada along the St. Lawrence River. There were 55 aftershocks ranging from 2.0 to 5.0. There were many small cracks in the ground. Pictured in the link that I gave you, the cracks were like 2 to 3 inches wide. They are pretty small, but 150 feet long. It also was in an area of many fault lines, and there were 200 micro earthquakes that occurred there every year. The lower elevation area caused by the impact of an ancient meteorite. So this was also a lower elevation, but the elevation was due to impact of an ancient meteorite. Okay, case study number 4. In 1906, the San Francisco earthquake happened. That was a very famous earthquake in California. It was an 8.0 magnitude, 5 miles below the surface. The ground shifted and cracked. There were many aftershocks and much damage, mostly due to fires that broke out. 80% of the city was destroyed. This was actually located on the San Andreas Fault. It's an active tectonic plate boundary where earthquakes regularly occur. The last case study, number 5, was the earthquake in 2020 in Salt Lake City. And this was a 5.7 magnitude in the southwest area of Salt Lake City, Utah. It was 8 miles below the surface. It had over 50 aftershocks. It was on top of a fault line as well. It caused damage to power lines and roads and also cracks in the ground. So you probably heard some patterns as I was sharing there. And as I did that, hopefully you recorded some of the similarities and differences between the case study you read about and the ones that I just shared. So as we close out the end of day 1, I want you to go home and think about have you or someone you know experienced or heard about an earthquake in the past? This is going to be shared, if you're comfortable, when you come back to class, some of these experiences that either people in your home or community have experienced. So go ahead and collect these stories on a piece of paper in your notebook. You can record them or just listen and learn. But what did they notice before the earthquake happened, during the earthquake, and after the earthquake event? And this will be shared out in class at the start of day 2. All right, we're going to go ahead and stop right here. If you have been absent for more than one day, you will continue on to day 2. Okay, welcome back. This is the start of day 2 for the Unit P.2 from OpenSciEd. If you were absent for more than one day or you have a block period that went a little longer, we're going to continue on with the next portion of day 2. For this, you will need a science notebook, something to write with, and the resource links will be found on a different bit.ly link, which is P2 Day 2. So you can see the link right there in the bottom left of the screen. If you want to take a moment to open it, go ahead and push pause and come back and push play as soon as you're ready to begin day 2. So remember that in day 1, we were looking at other earthquakes to help us figure out what's going on in afar and how that event happened or what any ideas about that earthquake by looking at other earthquakes and looking for similarities and differences. So you had the handout. It's the same handout that we have linked on the resource link here, but you're now going to complete step 3. So you're going to look back at your afar noticings and wonderings chart. That is in your notebook that we did on day 1. And I want you to, it's a little similar to what we ended with day 2. What similarities and differences do you see between your earthquake cases and the afar case? So think about all of the cases that we talked about after reading the case studies. What similarities is there to the afar earthquake? And what differences do you notice? And go ahead and push pause now and complete that last part of the handout, which is step 3. In your class, your teacher most likely had everybody share out their similarities and differences they found between the case studies and the events in afar in 2005 and some of the differences. So here's some of the big takeaways. The earthquake cases and afar had a lot of earthquakes around the time of the bigger events. So there were sometimes earthquakes before and a lot of aftershocks after. All of the earthquake cases seem to have cracks or shift in the land like afar. They also were all in areas where earthquakes do occur, and all of the earthquakes as well as afar occurred on fault lines. The differences between the earthquake cases and the events in afar, the earthquake cases are not near volcanoes, and the afar earthquake was near an active volcano. Also, the cracks seem way bigger in afar than the cracks that were talked about in North America. So for some reason, that afar crack was enormous. So that is a difference between afar and the case studies. So you may remember in lesson 1 of all the OpenSciEd units, at this point, we're going to try and put our ideas down on paper. We've got some ideas of why we think this is happening, but we're going to go ahead and put them on paper and create an initial model so that we can not only share our ideas, but also clarify our thinking to figure out what we are sure about or we think we know, and maybe what we're not so sure about. But there's no right or wrong answers. Just write what you think caused that large crack in the ground at afar, and also where that short-term shaking of areas near afar happened. And then also consider those earthquake cases. What's going to happen to that region in the future? So after the earthquake, it's done. What other changes might still occur in the future, and what might cause those changings? What interactions might be happening underground or on top of the surface that are causing those changes? And you're going to share these ideas potentially when you go back to class with your initial model. So if you go to the Day 2 resources, you will see that there is an initial model handout. If you don't have a printer, you can just use a piece of paper, but use this to guide you in what you're going to draw and label and what you're going to explain. So this was what the handout looks like. You're going to develop a model to help show and explain what happened below Earth's surface before and during the afar case, and to cause this sudden phenomenon. Where did that crack come from? The short-term shaking, maybe some volcanic activity, and possible causes of this phenomenon. And then you're going to, in the second box a little bit lower, you're going to develop a model to show the far region and how it might change in the future. So whatever you have in your first box is before or during the earthquake, and the second box is what's going to happen in the future. So go ahead and push pause now. You might either draw on the handout or in your notebook, and when you're done, you can go ahead and resume the video. So once you're done with your model, in class, you may have missed that there was a comparison with a partner. And so I'm going to go ahead and share a student model with you on the next slide, but I want you to compare your two initial models, the before and during and the after, to the one that I'm going to share with you. Now, on your model, go ahead and put a check mark to indicate where your models are similar. You both are in agreement. And then put a question mark to indicate where your models diverge, or where you might disagree, or where you might have questions. So you're going to mark up your model with a check mark for areas you agree with or are the same between two models, and a question mark where you're different or you're just not quite sure. So here is an initial model that a student developed, and you're going to go ahead and push pause, look at this initial model, and again, put check marks where you agree and question marks if you disagree or you're not sure about things. If you need more time comparing the models, go ahead and just rewind back about a minute and give yourself more time with this zoomed in model. Or you can try and push pause, and when you're done, you may resume the video. So in class, everybody shared their findings from comparing models so that we can now make a consensus model. And so people shared around the room things that their partner and they had in common, and they had their check marks, and we're going to put that onto a consensus model showing that the class really agrees on this. And then sometimes we're going to put question marks because the class does not agree. So we use the initial models and our comparisons to help build a class consensus initial model. So let me show you what one it might look like in a class. So your consensus model in your classroom may look different from this, but this is one example of the ideas that were shared by students. You can see that some students had forces on their model. So we represented that with an arrow. And then they said it came from the magma or it came from the crust. And some students weren't sure what magma was and definitely were not all in agreement that magma was causing that force. So we put a question mark, as you can see right here. So we're not sure about the magma. Also, in this, what's going to happen in the future, there might be smaller forces or larger forces and motion happening. So maybe a smaller earthquake and smaller motion, and a larger earthquake and larger motion. So students are thinking that more earthquakes are going to happen in this region. But we're not really sure where that small force came from and the bigger force came from. So we know there's some type of force, but we're not sure where it comes from and why they're different sizes. You can also see, obviously, I already mentioned the motion. So sometimes there's a lot of motion, sometimes there's less motion. And also there's energy transfer happening. So whatever that force is, there's energy going from one thing to another that's causing that shaking or causing that motion. Everyone also agreed that there's a volcano in the Afar region, and there was some smoke or an eruption at the same time as that first earthquake. So go ahead and look at this and see, are there any ideas here that you have on your model that also appeared on the consensus model? And then also make sure to ask your teacher to see the consensus model that your class created. So our model is trying to explain things that are both very big and very small. So it's helpful to keep track of the things that happen at different scales to help make sense of any connections between them. So let's see if we can put some of these observable events on this chart with the small space on the left and the large space on the right. Let's think about some of these observable events that happen and where would they go on that continuum between small and large spaces. At what scale did they happen? Let's start with the crack. Where would you place the crack on this small scale or large space scale? Would it be something that's small or large? And if we put it on a sticky note, we can maybe move it when we look at the other observable events, like the volcano. So compared to the volcano, where would the volcano go and where would the crack go? And here's an example of what one might look like. Also, the Afar earthquake. So students put them in this order. We're kind of not sure exactly which would be considered smaller. Is the earthquake a little smaller than the crack, or is the crack smaller than the earthquake? We were in a little bit of disagreement, so we put them both on the larger end, but there was some discussion about these two. And then the volcano seems to be pretty big, so we put that a little bit more to the right in the large space scale. So we came to consensus on our model about what might be happening at our earthquake cases. Let's look at those similarity and difference tables we did in that case studies, the case comparisons. What might we need to add to our consensus model that's not represented? Is there anything we left off? It seems that we did not represent plate boundaries, and we do have a volcano, but it's not on the second one. So should volcanoes be on there? Do they occur always with earthquakes? Because it seemed like it was only the Afar earthquake that had the volcano. So should that be on our consensus model? Should plate boundaries be on our plate model when these earthquakes didn't even occur on a plate boundary? So there's a few other things, and I'm sure you have more ideas of maybe what else needs to be included on this consensus model. But these are things we definitely need to consider as we begin to figure out what happened in the Afar region when this earthquake occurred. So here we are at the end of day 2. We've completed our consensus model, and we thought about what we might still need to add to it from those case studies as well as experiences that you talk to people in your community about. So we're going to go ahead and stop here at the end of day 2. If you also missed day 3 or on a block schedule and need to keep going, you may continue on. Otherwise, just return to class with the different things that we created for day 2. So welcome back to day 3 of lesson 1 of the P2 unit. For this day, you just need your notebook and a writing utensil. There are no resources that I have linked for you to use. So go ahead and get your notebook out and let's begin. So at this point in the lesson, we're going to make a list of questions that you have about things that we've considered so far. You can think back to that story map that we took some noticing and wonderings of in our notebook, that map of earthquakes where you were looking for patterns between the earthquakes and plate boundaries and volcanoes. Also, we read about the earthquake cases and we filled out that handout with the similarities and differences and the models we made, your initial model, our class consensus model, and also any experiences you talked with people about at home or in class, those extra experiences. I want you to consider all of those things and make a list of questions that you have that may help us figure out what happened in a FAR, or just questions that you have. So go ahead and push pause now, and you're going to record those questions in your notebook. Go ahead and push play when you're ready to resume. So here you can see some questions that other students asked. A big one, where is a FAR? That's a big question. There were some questions about the cracks, fault lines. There were definitely questions about fault lines. Also about that low elevation or plate boundaries. Why do earthquakes happen when there's no plate boundary? Also connections between earthquakes and volcanoes or magma, as well as it looks like all of these are kind of about how earthquakes are measured and why some are bigger and how much force is needed to make it bigger. So this is all about the size of the earthquake and the forces that maybe occur to make them happen at different sizes. So these may look similar to your questions. You may even have had a whole nother category of questions that you can add to. Go ahead and ask your teacher for a link to the driving question board or where it's located on the wall in your classroom, or what you should ask, what you should do with your questions if they should be added. The next part of this lesson, we're going to go ahead and brainstorm some ideas of maybe some data we could collect or the kinds of investigations we could carry out that might help us figure out some answers to those questions. So go ahead and make a new space in your notebook that just says investigation ideas, and list a few ideas of what you think we might do to figure out any of the answers to your questions or the ones that I just talked about. So go ahead and push pause here and make a quick list of some investigation ideas or even data we might want to collect. And our last task is to think about what's causing this earth to move and crack during an earthquake. You can go ahead and jot a couple ideas or thoughts in your notebook about what is causing the land to move. We kind of talked about that with the consensus model, but what do you think your ideas are? What's causing the land to move? And does land only move and crack during an earthquake, or could it happen where there's no perceptible shaking? So think about that for a minute, jot down a couple ideas, go ahead and push pause if you need some time. And then we are going to actually end day 3 right here. So we're going to stop here. This is the end of the lesson 1 of the unit for P2, and we're going to go ahead and close this out, and you now have all the things you need to return to class, and make sure you ask your teacher what you should do with it, and now you should be ready to jump in and join the rest of your class in figuring out all those questions we have about the Afar earthquake and earthquakes in general, where they happen, and have fun with the rest of the unit. Bye-bye.